Jai Hind, everybody. A lot of things are happening in the country. In the statement of Prime Minister, wherein we want to make India a developed country by 2047, and for that to happen, we have to have a substantial and robust development in the comprehensive national power of the country. Though there are multiple constituents of comprehensive national power, but defense forces play a pivotal role in that. Even in the diplomatic field, there is a more inclined cooperation between the foreign policies and military diplomacy. And in that, how well posed we are, not for meeting our own requirements, but also that of friendly foreign countries makes a lot of difference. In fact, you'll be aware that in case the country, any country for that matter in the world, has to maintain the strategic autonomy, it has to have the indigenous capability to produce the equipments with which it has to fight. And we have had, our good and bad experiences during the previous conflict. Even in 1999, when we had the Kargil conflict, we had one of our friendly countries, and we were denied, GPS access. Even the friendly countries charged us exorbitantly for ammunition which was required by the workforce, and these manipulations and these things keep happening the world multiple times, and therefore there is a need for country to develop a serious capacities in form of military industrial complexes. Number of leading countries in the world who are doing well in this field, they have an established system. But in case of India, these facilities have come, off and on in different places in a staggered manner. So we are very fortunate today to hear General N.B. Singh, who has been ex-DGME, who has done the pioneering work, and he will be talking to us on evolution of military industrial complexes in India, and especially the road ahead, because maybe we are not able to roll back something which has already come up, but then how do we go ahead to create conditions to meet our futuristic requirements? So before I invite General N.V. Singh, I'll request Kal Tushar to please introduce the speaker, and then we'll be privileged to hear him. Over to Kal Tushar Anand.
Thank you, sir. Good morning, everyone. Lieutenant General Dr. N.B. Singh, PVSM, AVSM, ASM retired, was commissioned in Corps of EME in 1973. The General Officer has a core specialization in armor fighting vehicle. He has undergone specialized training in Germany on off-highway vehicles and has stayed in Moscow as Deputy Military Attaché Technical. He has also been the DGME and DGIS. The officer has made stellar contribution in the field of indigenization of subsystems and spare parts of military equipment, establishment of production line for reset of import weapon systems like T-72, T-92, anti-tanks, UAVs, rocket systems, and radars. He has been associated in the design and development of bulletproof vehicle Takshak, Arjun armored recovery vehicle, anti-IED systems, and jammers. He has also been associated with Dhanush project and steered the installation of the indigenous auxiliary propulsion unit. He is a fellow of the Institute of Engineers. He was a founding member of AFT Jabalpur. He also holds a PhD in knowledge leadership and writes extensively on transformational leadership, defense industry strategy, defense manufacturing, and data analytics. I invite Lieutenant General N.B. Singh to give the talk, sir. Over to you, sir.
Thank you, Tushar. Is the presentation uploaded?
Yes, sir. Yes, sir.
Okay. So first of all, it's a great privilege for me to be delivering this talk on a very contemporary subject at CENJOWS. And for this, I thank General Ashok for giving me this opportunity. Now, at the start, I will just like to mention that I will not be using this term MIC in my presentation. I would rather stick to defense industrial base or defense industrial ecosystem, these terms which appear in our policy papers and various documents of the Ministry of Defense. This is one reason. The other reason is, of course, if you remember President Eisenhower's speech, farewell speech in 1961, he had talked about the MIC, and he had mentioned about the acquisition of undue influence by the military industrial complex. He did mention that we need to safeguard against it. So I certainly will not like the Indian DIB whenever it matures to acquire the size of the MIC, because we all know last 60 years what the MIC has been up to. So we'd rather like our DIB to remain a defense industrial base in support of the nation as well as the armed. So with that, now we go to the next slide. Yeah, please get on to the next slide. Yeah. Go back once. Next. Yeah. So let's first do a quick recap of these three terms: indigenization, self-reliance, and self-sufficiency. The capability to design, develop, and manufacture equipment within the country using your own skills and resources is indigenization. The capability to maintain, sustain these as well as equipment imported from other countries makes us self-reliant. And if all these activities are accomplished without foreign dependencies, we are self-sufficient. So these are the three terms I'll be using, and we should just know the subtle difference between these three. Next slide. Yeah, so here I'll just give a quick rundown of what all changes took place post-independence. At the time of independence, there was a near absence of DIB except for some ordnance factories which were manufacturing small arms and ammunition. And the country was totally dependent on large-scale imports from foreign countries. It was only post-1971 that certain equipment were offered by Soviet Union for manufacture under TOT, and these were done at the ordnance factories with some work share with the DPSUs. The private sector was kept out of it, except some MSMEs gradually came in, supplying components and certain parts. In 2001, the Defense Production Board and R&D boards were established. And since 2002, the process of, preparing the long-term procurement plan that was started off, offsets were introduced in 2005. And the first major change came when a defense production policy came out, which first time mentioned self-reliance as a strategic initiative. And this is the time when the defense production was liberalized and up to 26% FDI was allowed. Then, of course, the LTIPP was promulgated, the technology perspective and capability roadmap came up in 2013. What happened to it, I don't know, because nobody refers to it now. DPP has been in and around since 2002. I don't know, I have done 2 tenures in WE Directorate before 2000. One in early 90s and one in late 90s. We used to do good procurement at that time without the DPP. With the introduction of the DPP, I find things have become more complicated. Renamed as Defense Acquisition Procedure in 2020, and for the first time, the Make in India IDDM procedure was placed top in the hierarchy. So this indicates the inclination of the present government to want to go the whole way as far as indigenization is concerned. Now I have not included the Make in India here because there is a separate slide on that. Now let's see what are the pillars, what have been the pillars of our DIB till date. We start off with the ordnance factories, which has been a major pillar of the industrial base of our country so far. Next slide. Yeah, so here is a brief recap on the state of the ordnance factories. There were a total of 41 of them and 81,500 personnel in 2021. The major production used to go to the army. Capacity utilization was around 75%. They were corporatized in 2021 with 7 groups. 7 groups were created separately. The turnover in 2021-22 was 8,686 crores. It is projected to be around 26,300 crores in this year. So you can see that yes, after corporatization, things have really they are moving up. Off and on, CAG has highlighted institutions which are common to most public sector undertakings: time, cost overruns, quality, false promises, lack of spare supports, and absence of upgrades. You'll be surprised that the T72, which was rolled out in the early 90s, and the one which came out around 2005-6 was having the same configuration. No new technologies were introduced. In fact, some of those systems which were not available, the tank used to come out minus those systems. Same is nearly the same as the state of the T90, which started getting rolled out from 2004-5, the SKD versions, and now the fully indigenized version. So not much change in the equipment capability which they are offering. The biggest entity of AVNL of the erstwhile ordnance factories is AVNL, the Armored Vehicles Nigam Limited. Its turnovers are shown there. It is aspiring to become a $1 billion company. I think it should be able to achieve that in the next couple of years. We move on to the next pillar, which is the DPSUs. Next slide. Yeah. So as you all must have heard, there are 9 DPSUs. They are called the Navratnas. HAL is the biggest of them. The order book is full for several years. The turnover last year was around 30,000 crores. BEL is another very good DPSU, which is in the field of strategic electronics. The turnover touching around 20,000 crores. Then you have Bharat Dynamics Limited, Bharat Earth Movers Limited, Midhani, and the shipyards. Amongst the shipyards, Mazagon Docks turnover was 9,500 crores last year. Some of these DPSUs have diversified into aerospace, launch vehicles, railways, and metros and all. So therefore, their share in what they provide to the armed forces has dropped over the years. Now, one noticeable input is that there was very little in-house R&D in any form, whether it was in the DPSUs or in the ordnance factories. Except for the last 10-15 years now, things are moving in a positive direction. But I just give you a comparison. 20% is the amount put in by Thales in R&D compared to what BEL has been putting between 6 to 8%. And that's the reason why you find that almost all over the world, Thales systems are being integrated into major platforms. The general approach of ordnance factories as far as and DPSUs has been that they have been more of a systems integrator. If they want to integrate a radar, they will get most of the building blocks from abroad, like the pulse power amplifier. The crucial things they will get from abroad, and around that they will weave the whole radar system. Similar was the case with the ordnance factories. Even after manufacturing a product for about 20 years, they still had very critical dependencies on the sources abroad. Next, the third pillar has been the private sector since mid-1990s onwards. But initially, the private sector was kept away because of the Industries Development and Regulation Act, which mandated that core industries like atomic energy, defense, space, railways, etc., would remain with the government. So starting from 1950s, it's wheeled vehicles, generators, earth-moving plants, etc., that were being provided regularly to the armed forces. From 1991 onwards, when we started manufacturing Russian systems under technology transfer, some components and modules on build-to-print basis were given to the private sector, and they were doing it. A major change occurred in 1998 when a joint venture between India and Russia was set up, named BrahMos, and this is the shareholding there, and they have been doing a good job for the last about 2.5 decades or so. Since 2002, as I had mentioned, the private sector, the defense manufacturing was open to private sector, and the system of industrial licensing came in. As on date, 369 companies have been given the license, and the result of all this is to be seen. You must have seen the latest contract on the ATAGs, which has gone to 2 private companies. It has taken them 20 years, but yes, they have arrived now, the private sector. And we do expect that they will play a major role in the years to come. Next slide. Now, this is a special initiative which was launched by the government when the present government, when it came in power in 2014. They came in power in September 2014. The Make in India initiative was launched. As far as defense is concerned, some of the highlights are the IDEX initiative for fostering innovation and technology development. You have Srijan, where the 5 positive, the indigenization lists came up, and out of that, they have done till now about 3,400 crores worth of business. The Technology Development Fund under DRDO is there, which supports, again, domestic R&D. 2 defense industrial corridors have been established in order to, with the aim of creating hubs for defense production and generating employment. The defense acquisition procedure has been renamed and modified. You have the Aditi scheme coming up, where the amount of support, financial support being given is upwards of 25 crores in emerging fields and critical strategic defense technologies. Since 2020, a liberalized FDI policy has come in, where up to 74% is through the automatic route, and 100% a company can be totally foreign owned in the defense sector, provided the government approves it. However, not much has happened here ever since it has come. Roughly about 500 crores worth of investment has come under this policy of the FDI policy. So this is what has happened till date. Now, I will like to just compare 2 countries. First is Israel, second is China. Both these countries were in the similar situation as us in early 70s. In fact, we were a little better because we had access to some of the latest weapon systems, weapon platforms from the erstwhile Soviet Union. Now, Israel post the Yom Kippur War, where they were shaken to the core because of the surprise which was launched by the Arabs, and they ended up losing a large portion of their inventory. More than 800 tanks they lost in that war, and they were totally on the back foot. It was only because of some excellent work done by the Israeli maintainers that they could recover and regenerate close to 400 tanks, that Israel was in a position to launch a counteroffensive and stabilize the situation. So post 1973, Israel decided that enough, no more dependencies on foreign systems. We will go the indigenous way. The first thing they did in 73 itself, they sanctioned the development of the Merkava tank. It took them just about 5 years. They had some homegrown systems. They used that. They got some technologies from outside, integrated that. And by 1979, the production had started. And today you see where that particular platform has reached. It is one of the finest fighting machines in the world, crafted to their requirements, the kind of warfare they are going to fight, and not built around the attributes which are required possibly for a war in Western Europe or so. Now, they followed the human capital intensive growth strategy, where they first focused on creating the firepower, the intellectual firepower. So they used to identify and develop R&D talent in close association with IDF. You know, they have a system of 2 years draft. So all these young boys and girls used to come, serve there. They had a special unit where these boys were given access to defense technologies. They went back. Then in government sectors, private sectors, they started this R&D. They got associated with the R&D work. Now, third bullet is very important, all this work was done in close cooperation with the IDF. This is very important because without this, things will not move. They will move at a glacial pace at which they are moving with us. They used, of course, a blend of imported technologies and local innovation. And the US funding, US aid also helped them. They used to provide close to 66% funding for all innovative projects, which they are doing it till date. And of course, they created a knowledge base using all kind of means, global networks, etc. They also had the advantage that post collapse of Soviet Union, a large number of engineers and scientists of Jewish origin, they migrated from Eastern Europe to Israel. And today they spend close to 4.2% of their GDP. And you know what excellent work their companies are doing and exporting the kind of hardware and software, cutting edge technologies all over the world. Next is China. Next slide. China was also in a similar condition. Of course, initially everything was centralized under government control. They had 6 ministries of machine building. And initially they used to make old Soviet platforms, MiG-17, the T-59s, T-54s and things like that. But by mid-1990s, they corporatized all these public sector undertakings, which they had, and they adopted the IDAR approach, which is the introduce, digest, assimilate, and re-innovate approach, where they used to pick up systems from abroad, deploy them, understand them, then assimilate them, adapt to them into their conditions, find out what are the capability gaps, and they used to innovate and come out with a better version of the same platform. And this, in the initial years, we did hear of their missiles going awry, things like that. But then they were able to tighten their belts, and within about 2 decades, they were there. And now we see the kind of state-of-art platforms they are taking out. Today, most of the research is being done in the civil sector under the civil-military fusion strategy. This is the latest scheme which they have launched. They had the advantage that since they had the money, courtesy the economic transformation that took place there starting from the 80s, they had the money to buy Russian technology and Israeli technologies. The J-10 aircraft is reported to be based on the Lavi program of Israel, which was abandoned when they went in for the F-16s. According to Janes, around 10,000 enterprises, private and public, are connected to the PLA. So again, here it is the PLA which is in the driver's seat, and not any other peripheral agency. So this is the reason why things are moving as per a stated timeline there in both these countries. Now let's move forward and see what has happened in our country. Next slide. Here, this slide now. You see, we have been able to roll out some very, very good platforms like the Tejas, the Vikrant, indigenous aircraft carrier, a series of missiles, the Arjun, K9 and ATAGs, of course, are from the private sector. Then we have helicopters coming out from HAL. So the next slide will show you images of these platforms. Next slide. Yeah, so if you see these images compare with the best in the world as far as their appearance and styling goes. But the thing is that most of them have been integrated using foreign foundational systems, like the mobility, the survivability, the sensors, the armament. They all have been picked up from abroad and integrated. Now let's go into some details in the next slide, because we see what has happened in the Navy, because Navy is reputed to have done comparatively better than rest of the other 2 services. So let's see what the Navy has done when we compare the indigenous versus imported components in Indian warships. Indigenous, mostly hull and basic systems. Imported, critical systems. The dependency on import is shown there, whether it is propulsions, whether it's radars and sensors, missile and armaments, combat management systems, and like that, air independent propulsion. All these you find that there is a very strong import dependency. And this, of course, creates a vulnerability when it comes to life cycle support. Next slide. A very rough comparative readiness analysis between India and China as far as the Navy is concerned. In warship hull production, we are strong, but China appears to be a little more stronger. Then we come on to propulsion. You find that all our propulsion systems are mostly imported. China has a very strong domestic industry supplying these propulsion systems. The level of indigenization as far as radar and sensors is concerned is high. Missile self-reliance, with us it is partial, with them it is full. AIP, they have their own indigenous system, and therefore the net deduction which you can make out of this is that China's near total indigenization gives it a strategic edge in wartime sustainability. So when it is getting into it for the long haul, for a long duration war, there could be sustainability problems as far as we are concerned, until unless we have stabilized the supply chain and we are very sure that the foreign OEMs will continue to support us. Of course, they will extract their pound of flesh in form of jacking up the prices and all. But even if with that, if they are able to support us in time, then only possibly we'll be in the game for longer duration. Now, again, we do a comparison of the fighter aircraft, because China also, they have already demonstrated the 5th generation fighter, and recently last month they demonstrated the 6th generation fighter aircraft. So let's see the aircraft in the fighter scene. How much is the imported subsystems in our fighters? China, in any case, most of their systems are completely indigenous, and they have shown you that starting from the J7, J10 onwards till now, the 22 and the 35. So here in the LCA, you find that indigenous systems are restricted to airframe, F5 control system, EW suite, and the radar warning radar. So apart from these, otherwise, if you see, most of the systems, be it the engine, the MMR, ejection seat, displays, payloads, air-to-air missile, flight controllers, sensors, all these are all of imported origin. And therefore, it introduces a key vulnerability in times of operations. Next slide. So based on what we have been able to do so far, some key challenges which are there, we are still dependent on imports to a very large extent. 50% of most defense equipment is still imported. There are critical gaps in foundational technologies, not only in the jet marine field, but even in the land systems. You must have just heard last month there was a contract signed for import of the 1,000 horsepower engine. Now, I'll just give you a background that we have already taken 2 TOTs, one in the 80s for manufacture of a 740 horsepower engine, and another we took in 2001 for manufacture of a 920 horsepower engine. So 740, 920, and now we go ahead and take a TOT of 1,000 horsepower engine. So with this whole network of IITs and Indian Institute of Science and things like that, we are not able to scale up from 920 to 1,000 horsepower. So that talks about the academic firepower we have with us. We have a lot of ground to cover as far as foundational technologies are concerned. Foundational technologies are those technologies which are a must for any complex system, whether it is aircraft, whether it is land systems, whether it is marine systems. Then you have the slow procurement and bureaucratic hurdles. We know all about it. By the time we are able to acquire a platform, you find that obsolescence has already set in the country of origin. Private sector participation is still limited. Most of the big ticket items are still being given to the DPSUs. There has been a change now with the ATAGS contract, and of course there is R&D and technology lag, which is there. DRDO's story is mixed, but still I'll give credit to them. At least in the field of strategic systems, they have made the country self-sufficient. And today our dependency on advanced platforms is still there. We have seen the Rafale we had to import, the S-400 we had to import. We may import the next generation of fighter aircraft also before our AMCA gets ready in another 15 years time or something. So this is in nut summary the situation now. And now we move on to the main portion of our talk today, and that is the what needs to be done, the road ahead. So here I will just like to first give you a few basic slides in which I'll just compare as to what was done earlier and what needs to be done now. See, till now our acquisitions have been attribute centric. Find that the GS, whenever we want a qualitative requirement, it is gold plated to such an extent that the indigenous industry, the Indian industry, is not unable to develop it. Perforce, we now have to move to foreign countries. Foreign countries will only give you subsystems which are a generation or two older. So once he has made the next generation subsystem, then he is willing to give you. I'll give you the example of Arjun. When we took the Arjun RPAC, the MTU had already made the next series of RPAC. They already had that. So they gave us an obsolescent design. And the net result is that today, that design, they are no longer manufacturing that system. So now when you ask them that, look, I need power packs for my Arjun, he says, I'll take 4 to 5 years and I'll charge this much. Today, the cost of a power pack he's asking is 44 crores. In 44 crores, you can get a brand new tank of the T series. So this is our problem, that if you have too much of import dependency, this is what will happen 20, 30 years down the line. So I feel now is a time when we have to make a strategic shift, and our acquisitions have to become capability centric. In none of the GSQRs, I find any mention of the mission profile, what the system is supposed to be doing. So first of all, we must define the military capability, what exactly you want that particular system to do. And along with the acquisition of any military capability, it is very important that an industrial capability comes up and a technological capability also comes. So the industrial capability will manufacture that military capability, have the provision of creating the industrial surge in times of war, and the technological capability will come in to address the capability shortfalls. When I induct that platform at the LAC, a platform which was generally being used in the Western sector, when I introduce that in high altitudes, I find there is a capability shortfall because of the operating conditions there, or the kind of operational tempos envisaged. Now, I don't have the technical capability to insert technology and improve the performance, which I told you, the Chinese IDAR approach. A was adapt and R was re-innovate. So we should, whenever we buy a big, ticket item, maybe an aircraft like the Rafale, or maybe the system like the ultralight howitzer or any other thing, or the Apaches, we must ensure that people who are knowledgeable are associated with these projects. They then find out what is the industrial capability gap within the country, and the leverage of this high the capital intensive contracts must be used to set up these capabilities within the country. If we do that, all this will cumulatively lead to national resilience and help us to prepare for the long haul. So I think this major change has to come. We cannot afford to have a GSQR in which all known, systems found anywhere in the world are all integrated, and ultimately that GSQR now looks at getting a wonder warfare or a wonder weapon, which nobody will be able to provide you. So the Indian designer is compelled to pick up things from abroad and try and integrate it and give it to you. The cost of that, of course, is I've told you what happens. Next, now let's just understand military capability. These are things which I'm sure many of us know about it. It is basically the ability, and when I talk of military capability as related to equipment, I'm not talking of the human resource element. So it's the ability to achieve a desired effect in a specific operational environment. I want to do something with my platform at the LAC, I should be able to do it with a very high probability that there'll be no breakdowns. So military capability is defined by combat readiness, sustainable capability, the capability which comes if there's a breakdown, we should be able to quickly recover, repair, and regenerate. Depends on the force structure. From the equipment point of view, it represents the assets which are there to perform those combat functions. And the type of technology decides whether you are a force with low levels of technology, medium levels of technology, or a high-tech force. So the American armed forces are known as high-tech forces, or the Israeli armed forces are known as very high-tech forces. We are struggling somewhere between low and medium. We have to graduate to becoming a fully technology-enabled military, and that can only happen if you have your own indigenous industrial and technological capabilities. Next slide. Yeah, maintaining military capability implies modernization and sustainment, because as the next slide will show you, just by acquiring a military capability, you cannot then sit and say that, okay, for these 20 years now I've done enough. No, this capability, because it is so complex, it requires to be maintained, and you have to do periodic technology insertion. You have to have a complete setup for first, second, third, fourth line servicing and things like that, because the existing military capability, the wars have become so spontaneous, so I mean, you really can't predict. Earlier, you used to talk about of 30 days, it will take to concentrate in the concentration area, then move to the assembly area and things like that. None of those will happen now. Examples in Ukraine and LAC have shown. So you will have to get into it with what you have. You can't do much about it. You can do little improvements in the state. And unless you don't possess the desired industrial resilience and maintenance surge for the long haul, you will be in trouble. This is what happened to the Russian forces. I mean, in their march to Kyiv, they never ever imagined that they will end up with a 40-kilometer traffic jam. And that gave the opportunity to the Ukrainians to, destroy them piecemeal. So it ended up in loss of reputation of a wanted force. Before that, everyone thought, they all used to remember the achievements of the Red Army in World War II. But of course, the other lesson is that just because Russia possessed the industrial resilience, they were able to bounce back into the war, despite the rest of the world supporting Ukraine. So this is the importance of military capability. And in the examples I have given, it is also linked to industrial capability. Military capability can only be sustained with an indigenous industrial base, which, once we see the constituents of a defense industrial base, also has elements of technological capability. So it is all interlinked, and we have to take a systems view. It can't be just plain procurement. Plain procurement you do for shoes and socks and things like that, and tents and general stores. you acquire a military capability, you acquire a complex platform, you don't procure it. This thinking, this change in the thinking process, in the thought process of the acquisition community is a must. Next. Yeah, generally, most armies, adopt a kind of a preparedness cycle when they decide to change their equipment. And the various steps of this is shown. The last one, of course, is evaluate and improve. Our northern neighbor is reputed to be doing this after almost every exercise. They carry out this kind of evaluation, and their aim is to ensure that every next generation of the equipment which comes in must have improved equipment capabilities. At least they should have improved the capabilities at least by 10%. A very modest aim, but this is how they they carry out this process of continuous product improvement. So they will evaluate something at the LAC. They find that, okay, our light tank was having these kind of problems at 18,000 feet, at 19,000 feet. They go back to the lab and address that problem. Unlike us, where we continue to operate with that problem. Because I have not seen this kind of a cycle being ever talked about or discussed in our war games or exercises. In fact, the equipment is never discussed. Just everything gets discussed there. Next. Yeah, so this is an interesting slide where I will just like to mention that, there are certain misunderstandings with most of us regarding the capability. We feel that we have inducted a weapon system, for example, the ultralight howitzer, and so everything now will be hunky-dory for the next 10, 20, 30 years. It is not. The capability which you acquire, and now I'll talk in terms of numbers. Let us assume that when we picked up the ultralight howitzer, it had the ability to fire 1,000 rounds without failure. So everybody was confident that if I take it into battle, I'll be able to fire at least 10 second lines without any problem. So 10-second line means 6, 7, 8 days of operations, no issues. But that is not the case. With passage of time, almost every year, you end up losing or degrading your equipment capability by 3 to 4%. This is recorded through studies. In our case, it will be more because most of our weapon systems platforms are all warehoused in the open. At least that was the situation when I retired in 2014. If things have improved in the last 10 years, well, very good. But otherwise, we can expect that any capability which you pick up will start degrading as a result of age, usage, and deployment by at least 2 to 3% annually. And therefore, this capability keeps coming down as shown by the yellow curve there. Now, what is the job of the maintainers? The maintainers' job is that using the servicing schedules, medium and base resets, they try to upscale this capability and keep it as close to 1,000 rounds as possible. Now, when you have a system which has been made in India and things are available, supply chain is local, you are able to pick up things and do this job neatly. But when you are dependent on imports, as in the case of ultralight howitzers, either you must provide that kind of budget to get the items from abroad in time so that the job can be done. Otherwise, what you do is you do a kind of a half-baked job, what is known as band-aid servicing. You do that and you send the whole thing out. Now, this band-aid servicing ends up reducing the equipment capability. We saw an example of this in the Kargil war. Nobody talks about it. But it did happen there. Fortunately, it was a localized, one brigade sector conflict. Nothing erupted. Now, what happens that if the next capability which you are planning, say you want to introduce another towed howitzer or a mounted gun system, if that doesn't get inducted in time, then there is a capability gap which arises. Your systems are unreliable, and if something, God forbid, if you have to go in for war at that time, then you are likely to face problems. This is what happened with the Russian military when it moved in. They were using all kind of antiquated equipment, not serviced. They were all warehoused. They just took them out, did some little kind of gave a bandit treatment to them and moved on, thinking that, we'll be able to reach and encircle Kiev, but they were not able to do that. So, and there are a large amount of, images available on the web. You can see them. They're even, very, very complex platforms like Pansir missile system also was grounded. So next slide. Now we come to, first of all, a little clarity on what are the constituents of a defense industrial base. As I mentioned, we have the prime contractors or systems integrator. We all are clear, AVNL, ordnance factories, Larsen and Toubro. These can be taken as the prime contractors or systems. They have the capability to integrate a fully fledged system, be it an aircraft or a tank or a gun system. Then you have partial system manufacturers. They manufacture independent systems like radar or a missile, which can be used either in a standalone mode or it has to be mounted on a platform to deliver a capability. So in this comes BDL, Bharat Electronics, and certain other, the BrahMos. All these are they can be taken as a partial system manufacturer. You have then subsystem manufacturers. These are specialist outfit that manufacture foundational modules. Now there is a complete scarcity of these kind of subsystem manufacturers in India, and perforce our designers have to then pick this up from abroad. You have seen the case in the Navy also. They pick up the gas turbines from abroad. The Air Force has picked up all their engines from abroad. The Army also has followed suit. In the latest light tank, you find that the whole system has been picked up from abroad. So we do not have subsystem manufacturers within the country, and there is a need for private sector to enter into the space. Next. Component and next, just go back one slide. Component and agreement and aggregate manufacturers, whereas this is generally restricted to the MSME sector. They make those line replaceable units, shop replaceable units, aggregates, assemblies. We have plenty of them in India. Only thing is they don't have enough work. Otherwise, you give them the drawings, they will be able to produce a better item, qualitatively better than what is coming from abroad, at very affordable prices. I can just share with you that something which was available for $5,000 in Russia when I was there, we were able to get it for 50,000 rupees in India. So that is the price variation. Design houses, you all know, these are the design authorities who have unique systems engineering skill, and they are equipped with all kind of CAE tools to test and prove systems. Today, this capability is only available with DRDO. In small forms, it is coming up in the private sector like Tata Power and Bharat Forge, L&T, etc. But majorly, it is with DRDO. And finally, lastly, you have anchor institutions. Earlier we were only dependent on the institution run by DRDO, that is the DIAT. But now, last 10 years, some IITs have also taken up defense-related projects, and they are doing a good job. Now, this is where Israel and China had invested, in their design and development capabilities, in their knowledge, what are known as knowledge-based organizations, KBOs. They invested in that, and the result of that is for all of us to see. So it's time that I have identified 3 gaps here: design houses, anchor institutions, and the subsystem manufacturers. These are areas where the private sector needs to come in an aggressive manner and create capabilities, in case if we want to, in the next 20 years or so, we want to establish a versatile defense and a strong defense industry. Next slide. Yeah, this slide is very interesting because this clarifies in one shot, in one image itself, you can know the perils of dependence of too much dependence on imports. If you see any complex platform, be it an aircraft or a ship or a land system, the acquisition cost is what has been shown above the water level and in red. So that is the cost of research, design, testing, production, construction, and all that. Now, when you are buying these systems, today's systems are so expensive that you are perforce constrained to keep it for 3 to 4 to 5 decades. Earlier, if you see in post World War II, the starfighter came in about 15 years. It was discarded. But then when the F-16 came, it came in the mid 80s. It's still continuing. The Abrams tank came in the mid 70s. It is continuing. Why? Because these have become so expensive that the country finds it very difficult. A country like America also finds it very difficult to get rid of the F-16. So what they do, they keep doing periodic upgrades to refine their capability, to optimize their capability. Now, when you acquire a system from outside, just see the costs which you have to bear during the life cycle: operations cost, software cost, maintenance cost, inventory cost, training cost, all these. So you end up spending anything between 3 to 5 times the acquisition cost during the life cycle. So if we have bought the Rafales for, say, about 55,000 crores, we should be prepared to spend anything between 4 to 5 times that amount over the life cycle of the Rafale, which should be anything between 40 to 50 years. Now imagine if all the systems of Rafale were being produced within the country, then what a multiplier effect it would have had on the domestic economy, with all this money being pumped back into the Indian industries. But what will happen is most of it will go back, will have to be remitted to the OEM because he is totally in charge. So this slide in one shot indicates the perils of too much of dependency on imports cost wise. Second, of course, is the operational vulnerability which you introduce, because if you don't get a thing in time, then what do? You resort to the famous practice of using hanger queens. You start cannibalizing. So there are few platforms, they just remain static. You're picking up parts from there and trying to see that the serviceability rate is somehow, remains within acceptable limits. So this slide also, dictates that how important it is to go in for a local defense industrial base. The next slide. Yeah, this just a very brief introduction to it. It is very important now, that whenever you pick up a capability, you should be able to ensure that this capability remains in a condition in which you want it. That means 1,000 rounds. If I had the capability at the start of acquisition, when I inducted it, I must ensure that the gun fires 1,000 rounds without major failures or near 1,000 rounds throughout its life cycle. And if we are able to do that, then we say that, yes, my gun system is in a ready to fight condition. So this is only possible if we give a true life capability readiness kind of a look to all our acquisitions. That means an acquisition now has to be managed from cradle to grave. The time you conceive it till the time you discard it, you have to plan the complete sequence of events. What will you do? When will you do a medium reset? When will you do a base reset? When will you do an upgrade? What kinds of upgrade? Because when you plan this over the life cycle, then budgetary provisions can be made instead of suddenly making a demand for because all these projects are very capital intensive. To just give you an example, we must have bought the Bofors for about 300, 350 crores. I don't remember. The amount was somewhere around that. Let's take it as 400 crores. In 2003, post-Kargil, when we found that the performance of the guns were not up to the mark, we went in for a major overhaul of that. For only 100 guns, we had to pay 350 crores to buy the spare part from Sweden. So that's the kind of money you have to put in if you don't plan things in advance. So therefore, this concept of through life capability readiness, it is time that along with our acquisition process, this also is given the required thought. And finally, now the last 2-3 slides where we'll talk about as to what exactly is the need. Okay, one more slide on this, of course, self-explanatory. I think we can skip this slide. Not much is there, except there was one point that it is time that the military starts accepting indigenous solutions which meet the QR up to 80%, rather than wait for perfect systems. I think this is something where it can generate some interest in the question answer session. We leave it at that. Now, next we move to the strategy of self-reliance. So in the backdrop of whatever I have talked till now, what I feel is that if we have to achieve self-reliance, we have to do indigenization, and we have to become near, I'm not saying full self-sufficiency, but near self-sufficient, then it's a big task. And a long-term view of 2-3 decades becomes important. In my view, we should aim to achieve comprehensive technology security and technological parity with the strongest neighbor of ours by 2050. That should be the goal or target we should set in, because technological dominance of the kind which US has enjoyed over all its adversaries is far off for us, because we know the kind of neighbor we have in the north, whose capabilities are enormous. So as long as we look at becoming self-reliant and also achieve some kind of technological parity against this adversary of ours by 2050, I think we should be satisfied. Now, the important thing here is to have a strategy, because today, sadly, there is neither a defense industrial strategy nor a defense technology strategy. And as our foreign minister has mentioned, Mr. Jaishankar, in his book, Why Bharat Matters, he has mentioned that, moving without a strategy is like driving without knowing the destination. So you just don't know where you will be landing up finally if you don't have a strategy. So it's important that we spell down the strategy for all conceivable fields, whether it is land systems, it is cyber, whether it is aerospace, maritime domain, sensors, surveillance, target acquisition, every conceivable vertical has to be looked into detail. And what do you want to do? What do you want to do in India? What do you want to pick up from abroad, from your friendly nations? And what is the surety of or the stability of that supply chain? So it is very important to go in for this. And the next slide, which I will show you, is basically talking of the mechanics. How do we go about doing it? I call it the technology-free approach. And before I expand it, I will just like to mention that Dr. Abdul Kalam, in his book, My Journey, Transforming Dreams into Action, has talked about his mentor, Dr. Vikram Sarabhai. And he said that when Dr. Vikram Sarabhai took over the space, the leadership of the space domain of ISRO, he was very clear. He was very clear that strategic autonomy will only come if we become self-sufficient in almost all technologies and systems associated with space launches. So he gave a full systems view to this whole business of space, and he commissioned at that time in the 70s, he commissioned programs on advanced materials, on telemetry, on payloads, on instrumentation, on satellites, on launch vehicles, everywhere. There were some successes, there were some failures, but ultimately they were able to achieve a high level of self-reliance in that. And today it is courtesy the vision of Dr. Vikram Sarabhai that ISRO is well placed, and it's become a force to be acknowledged world over. So what is important therefore is that people who are leading the charge here in the Ministry of Defense needs to have a systems view, a full systems view. Full systems view means you should have an operational view. It's not good enough that you just simply have an operational view and you say, okay, now I can take charge. No, you need to have an operational view, a technological view, and a sustainment view combined together. Then only you can create capabilities which will last you for 30, 40 years. Now, till now, we were only looking at this. If we have to make a land platform FICV, I look at the hull, the turret, and the electronics. I look at what all systems are required here. I talk to my suppliers abroad, get it from there. What is required in turret, I get it from there. What is required in vehicle electronics, I pick up something from India, something from abroad, and I integrate it. The light tank is a classical example in this, where almost 90% of the items today in 2025, 23, 24, whenever they made it, are all imported. The whole turret is imported, imagine. And you're going to make 59 numbers of these. What kind of indigenization will you do? Because there'll be no economy of scales at all. Now just do a few more clicks. So the whole diagram will then pan out. Now I'm just trying to show you that a person in charge needs to have a view like this. Like Dr. Vikram Sarabhai, he must understand up to the right and lowest nut and bolt that this FICV is going to have about 31,000 components working in unison. There'll be at least 60 to 70 systems, subsystems. All these are required to be developed in India or majorly developed in India. And if he knows this, then only he'll be able to, roll out programs for indigenization of these subsystems. So it's very important that the whole mechanics of indigenization or self-reliance revolves around the technology tree. Now we come to the last two slides. Yeah. So I have told you that we have to have a strategy. We have to have a long-term plan spanning about 2 decades. And in this strategic plan, we can have short-term plan, which is till about 2035, which looks at initially the first point is about covering risk. So somebody says, I need a new tank. What we can tell him is, look, friend, I want this tank to be 70%, 80% Indian. And therefore, what I am willing to do is I am willing to spend something, you carry on, you go on onboarding new technologies in your existing system, make it future ready for at least next 10 to 15 years. I will give you a new tank only after 20 years. So in these 20 years, what do? I first do large scale indigenization of all the spare parts so that hollowness is plugged. The MSME sector gets acquainted with kind of defense, aggregates and components it has to manufacture. Then I ask for some subsystem manufacturers to come up and start making systems which ultimately can fit into platforms like Arjun, Dhanush, LCA, LUH, etc. But these should be the indigenous systems. And I'm not going to touch my operational platforms. I must have the liberty of having a few numbers of experimental platforms where I fit these and keep testing them. And simultaneously, I must allow private sector to get into the subsystems where they carry out R&D. Government can fund them up to 70%, 75%, whatever they are. But there is a need that the private sector gets into the development of foundational modules for firepower, survivability, propulsion, materials, and things like that. So this is the preparatory period up to 2035. This is how we should move in a very calibrated manner to create capabilities in our institutions in the MSMEs, in private sector, and then the long term. Next slide. Yeah, long term. Then maybe 5 to 7 years from now, we launch some de novo IDM projects covering the land, marine, aerial, high altitude, all kind of domains, and with the stipulation that 75% of the major systems, foundational systems, will be indigenous. Remaining 25% can be picked up from everywhere and manufactured in India. But we will not allow foundational systems, which were imported in the 80s and integrated. We will not allow the same practice to be done now, as has been done in the case of the light tank, because that's a retrograde step. It is time that indigenous platforms get integrated. I'll just give you the example of the J7, the fighter program of the Chinese. The earlier versions of the J7 had the MiG-21 engine from Russia, the RD-9 or something. The later versions, they made their own engine. They had a lot of problems because it was being done in the late 70s and 80s. They didn't have the technologies. But yet they mounted their engine and flew the aircraft. The aircraft flew for just 17 hours. After that, the engine failed. But a lot of lessons were learned from that. And they continued WS6, WS7, and went up to 15. And they were able to, master the technology and come out with their own aero engines. And today you see almost all the aero engines are powered by their own systems. So that is the kind of approach we have to adopt if we really want to go into this, become self-reliant and self-sufficient. Then other slides are there, which I think you can read. Innovation, obviously, you have to create an ecosystem where innovation flourishes. Invest in unproven technologies, at least a few of them, where we should become the world leaders. The way China is, launching disruptive technologies off and on, we should be in a position to do at least in a few fields. The knowledge of system design and integration, which is now available only with DRDO, needs to be shared with the private sector by working together so that private sector design and development skills also come up. Of course, we have to make use of the human capital we have. We talk about the youth dividend, but till the time we don't train them, we don't develop their skills and competencies to innovate ahead of the rest of the world. This is the term I have used, that our younger generation must be given the freedom and the opportunity to innovate ahead of the world. And not the kind of innovation which we are seeing here, the aggregation of Zomato and Swiggy. And of course, the budget has been around 0.7, 0.8% now. GDP, if we really business. So with this, gentlemen, Ashok had mentioned that we are looking at 2047. And be very good in case the Indian military also draws back. By the time India's vision of becoming a Viksit Bharat comes to fruition, the Indian military also transforms into an integrated, technology-enabled, agile fighting force, which can give a strategic assurance not only to its troops, but to people of India, that we are there to guard your safety and well-being. Whatever are the capability gaps which are there in our industrial capabilities, the diplomatic corps has to work to see that these get plugged in. The leadership, the political leadership, must have the strategic vision for the long haul. They must provide all support to see that the vision of the Indian Army, Indian Armed Forces becoming a tech-enabled force by 2047 or so is achieved by providing required budgetary support and finances. And finally, it is up to the Indian military. I've given you examples that without the military being a part of this pack and at times leading this whole team, this vision of establishing a strong defense industrial base will not come to fruition. So that's all, ladies and gentlemen. Thank you so much.